Let's teach them. Can they help me? Today we're talking about water heater elements and how they work. All right, so I'm going to draw up a couple things on the whiteboard to help explain how this works. And if you guys have any questions, just let me know down in the comments. All right, so we're going to start off just drawing a water heater. Your basic water heater has 2 square panels. They're supposed to be about the same length, same height. Not that great of an artist, all right? You're going to have a thermostat for each of them, and you're going to have your element for each of them. Right. So let's take a look at the actual element itself here. This is typically what they look like. Sometimes they have multiple wraps. They can come in different sizes, different lengths, definitely different colors, made out of different alloys, possibly copper or Incoloy. Different styles can be made, but almost all of the time you're gonna have 2 screws right here on the end, and basically you're just sending electricity into one side and it's going to come back the other side. That's all that you're doing. And here there are a couple different numbers. Most of these run off of 240 volts or 208 volts. This one is actually a 4500 watt 240 volt element, which is most standard that you'll see in most of your water heaters. Almost all of the water heaters that you'll come along are going to have this 2 setup. Most of the time they will run separately, meaning that these are not both going to be heating at the same time. Most of the time, power is sent to one of them first. Once that one is satisfied, that one goes away and it sends power down to the second one to heat the other half of the tank. All right, so let's zoom into just that upper panel right now and see how these things work. All right, so most of the time, this is about what you're gonna see in your upper panel. You're gonna have your upper thermostat and you're gonna have your upper element, right? So here's a couple things to point out. First off, you're gonna see a big red button right here in the center. That is your reset. If you go to a call and that reset is tripped, there's a couple different reasons why that might be, and we'll go over that here in a few minutes. But first off, you have 120 volts coming in one leg, and you have 120 volts coming in on the other side as well. For a total of 240 volts, right? Okay, beautiful. Next, we're gonna get we're gonna use all of these colors. You ready? Most of the time you have a blue wire going from here to that side. You have a black wire coming out of here as well, and you have it going down to your lower thermostat. This is a yellow wire, okay? That's usually the color it is behind there, but because I don't have yellow, we're gonna use green. So that's a yellow wire. And then the last thing that you're gonna see is a red wire coming off of here. Also going down to your lower element. I know this looks very confusing, but one thing to remember. If you ever need to take this apart, take a picture before you take it apart, okay? It's gonna be much easier to put back in place, and you're not gonna forget which wire goes where, and you're not gonna blow anything up, don't worry. It's super easy, super simple. Once you see about 10 or 15 of them, you're good to go. So you have your power coming in on the top. You have power being sent constantly to this screw right here. So you have one side of your element always gonna have 120 volts to it on both your top and bottom element, yes. Now this one here in the center, this acts as a switch, okay? So whenever you turn your water heater on for the first time, it's going to heat the top one first, and that's gonna put the switch over here on this side, sending another 120 volts to this side, creating 240 volts and turning that element on to heat the water. Once this thermostat is satisfied and that has heated, it is going to switch this power leg over, and it's gonna send the power down to this leg. Like I said earlier, you have 120 volts on one side of your element going to the bottom. And whenever you switch this over, this sends it to the red wire that's also going down to your bottom element. It'll turn that side on and get that one heated up as well. So going a little bit deeper into testing and seeing if these elements are working properly. Let's say you show up to somebody's house and the reset has been tripped and you need to figure out why they have lukewarm water, right? First things first, turn the power off to the unit before you start working on it. Once you turn the power off, go ahead and test these two top terminals. Make sure that you have 0 so that you know that this thing is totally safe to work on. Next thing you want to do, since you know you have the power off, you want to take the wires off of both or your top and your bottom elements, right? You want to take these loose, move them out of the way, do whatever you got to do so that you can get to those 2 screws right there, because you're going to test for continuity. What does continuity mean? Continuity, I'm basically just testing from either side of these screws. I want to make sure that I'm getting resistance between here and here. It's just traveling through this element and coming back. I want to make sure that there's a value of some sort. Typically on a normal water heater with normal elements, you're going to get somewhere in between 11 to 15 ohms. That's pretty typical, pretty normal. If you're getting a different reading than that, most likely there's something going on with the element and it needs to be replaced. So boom, boom, we go ahead and test this. That one's good, cool. We move down to the bottom one. We test this one. This one's giving us an OL. What's that mean? Well, there's a couple different things that could mean. For example, if it's OL, that means there's probably a break somewhere in one of these lines and it's not getting any of that power sent back to the other side of the screw. So it's OL, which is overload or over limit, meaning that it's an infinite amount of number and it'll never reach back to the point that you're testing to. So let's try another thing. Say that doesn't happen. Say you test this bottom element here. It's giving you a weird rating like 1.05 or 2.48 or something weird. You go, that just doesn't seem right. Josh said it was between 11 and 15. So, why am I getting this strange reading? The next thing I want you to do is take your leads. I want you to test one screw to the side of the tank. When I'm talking about the tank, I'm talking about something metallic, something that's going to ground you to the system so that you can test to see if this is shorted to ground. If you're getting any sort of reading when you have one lead on your ground and one lead on a screw of your element, if you're getting any reading at all, that means that it has shorted to the ground. That means it needs to be replaced. Now, if you're getting OL in this situation, that's correct because you don't want there to be feed through your ground. Here's my quick order of operations when you're testing and diagnosing an electric water heater. First, I want to turn the power off. I don't want to get electrocuted. I don't like electricity. I'm a plumber, okay? There's a reason why I chose this trade. I didn't want to really mess with electricity, but because I work on water heaters, I have to know what I'm doing here. So I'm going to be safe. I'm going to turn the power off first. Second, I'm going to remove the wiring from elements. I'm removing the wires now that I have the power off to my elements so that I can test for continuity, testing the ohms. We're looking for 11 to 15 ohms of resistance right here. Once I've done that, I'm going to testing. I am testing short to ground. Testing short to ground is basically me testing on putting one of my leads here and putting one of my leads on the tank itself, the metallic part, yes, so that I can test to ground. Make sure that this thing is not grounding to the tank. If it is grounding to the tank, it needs to be replaced and it will not work until you do. Another thing I'll check is to see if the reset is tripped. If the reset is tripped, obviously you're going to have to reset it so that you can send power back there correctly. But once you know what's going on, one of these two things, we're going to check for ohms and we're going to check the test to ground. That's typically going to tell you what's going on with that water heater if it's giving you troubles. If your customer said it got overly hot before it got cold, usually that's a thermostat problem, meaning that it's not shutting power off to one of the elements and therefore causing the water to heat longer than normal. If the customer's complaint was, no, it was just really lukewarm and it's been like this for a while and I don't know why I'm not getting a full hot water. Typically that's telling me that the lower element is no longer working properly. In the order of operations for an electric water heater, it sends power to your top element first because it draws the water from the top of the tank, and then it sends power to the bottom of the tank to heat the bottom half of it. So if you're getting half of the hot water, that means that it's satisfying the top part of the tank, sending power to the bottom, and because that is a bad element down there, it's not going to heat the tank fully. Now, when you call for that water and it's lukewarm, if you call for enough water, it'll send the power back to the top and reheat the top half, but it'll never give you that full hot water that you're looking for like you used to. All right, I know this was a little bit longer of a video today, but hopefully this gave you guys a little bit of information on how electric water heaters work. And if you guys do have any questions, please let me know in the comments.